Okay, so we're talking about intermediate value theorem. What I have up there on the board is exactly from the book. Book's a little confusing. Okay, lots of algebraic and calculus notation. Maybe just a little bit confusing. Okay. Here's really what it is saying. Let's think about our speed situation we talked about. At some point in time, I know I was going 60 miles an hour, okay? So at some point in time, I know I was right here. And then at another point in time later, in our instance, we were right here. So this is my f of A, this is my f of B. What the intermediate value theorem is basically saying is I can guarantee you that if I pick any y value between f of A and f of B, there has to be some c value here such that f of c hits that y value. There has to be some x value between A and B such that f of x equals that y value that's between f of A and f of B. In other words, I need to hit every y value from here to here, and I guarantee there's going to be some x value that results in us hitting that y value. Okay? I know there's no way to go from here to here by skipping a y value. Okay? Who knows what I did? I might have gone up and come back down, that sort of thing. Okay? But if I have a continuous function, the intermediate value theorem is stating I must hit every y value between f of A and f of B. And you can find that y value because there's a certain x value that is paired with it. Yes, no, thoughts? If f is continuous on the closed interval AB, is my graph continuous on the closed interval AB?
Yeah.
Did I ever have to lift my marker up off the board? No. Okay. Does f of A equal f of B? No, it does not. They're clearly different amounts. That would be a problem. Yeah, I mean, going back to the video, if I was going 60 miles an hour now, and then I was going 60 miles an hour again 10 seconds later, I have no idea if I was going any other speeds or not, okay, if they cut that video off. Alright, there's no way to know if I just was going 60 the entire time, if I sped up or slowed down, okay? So, if I have a continuous function, and f of A does not equal f of B, then for any k value that's between f of A and f of B, there exists a c somewhere between A and B such that f of c is equal to whatever that k value is. Okay? That's kind of confusing. Alright, I think. If you had to put the intermediate value theorem in your own words, how might you try and do that?
F of c is this.
Nothing?
Any x value, or any y value in between 2 points has an x value.
As long as...
As long as it's continuous.
Okay. Would it help you to try and do this intermediate value theorem using that speed video that we talked about? If I knew I was going 60 miles an hour at one moment in time, and then I was going 100 miles an hour 10 seconds later, I know for a fact I have to hit every single mile an hour between 60 and 100 on my way. There has to be a moment in time where I hit every single other one of those values between 60 and 100.
Every single y value on a continuous line.
Okay? I mean, if that makes sense for you to put it in that context, to help you think of the intermediate value theorem, then write it that way. Okay? I'm not going to ask you to write this. Okay? In a nutshell, the intermediate value theorem just says if I got a continuous function, I guarantee you I hit every y value from here to here. Guaranteed. There has to be some x value that helps me hit every y value from wherever I started to wherever I stopped.
So it can hit more y values just...
It could, yeah, like this one did. It went above f of b.
Yeah.
But there's no way to know for sure which one's above or below it hit, but I guarantee you it's going to hit every single one between f of a and f of b. So that's what the intermediate value theorem is saying. I'm going to ask you, put the intermediate value theorem in your own words. And if you want to use the speed idea to talk about it, do it. Okay? I really don't want to see this. Okay? Because I don't want to read it. Okay? Put the intermediate value theorem in your own words. Intermediate kind of means between, right? Okay? Intermediate value theorem, I guarantee you that as I go from one point to another point, I will hit every y value from my starting point to my ending point as long as the function is continuous. Or use the speed example. Alright? A type of problem you might see. This is kind of an algebraic problem. Okay, so here's a type of problem you might see. Here's a function. I want you to, using calculus, verify or prove to me that this function has a 0 somewhere on this interval. So somewhere from 0 to 1, I want you to show me or prove to me that this function crosses the x-axis, that it has a 0. So what might I do? Plug in 0 and plug in 1 to essentially find our y values, right? So what would f of 0 equal?
1 cubed plus...
So f of 0.
Oh.
Negative 1? What's f of 1 equal?
1
So f of 1 would be 2? So I know that these are 2 coordinates on this graph. So using the intermediate value theorem, using that idea, I know the function must have a 0 on the interval 0, 1. Okay, if you just write that, I'd be fine with it. I don't know where, but I do know that it has to have a 0 at some point. What if both of these y values were above the x-axis? Could you verify that it has a 0?
No.
No, you have no idea. Could it?
Yeah.
Maybe. Alright. Now obviously if we wanted to actually find the 0 and that sort of thing, I would just go ahead and graph it. I would graph it and have the graphing calculator calculate the 0 for you, like we did in Algebra 2 in Advanced Math. Okay? So that's our intermediate value theorem. I'll let you guys do a couple problems on that before we get into the squeeze theorem. This will be on page 80. There's only 3 of them. Page 80, 83, 84, 91. Okay. Try those. Need to use the restroom or get a drink here next 10 minutes or so. Feel free to do that. Marcia, want to stop on that, please?
Alright.